strategy, consulting as an analyst, developer, and knowledge management lead. She has a strong track record in delivering outstanding results, distinguished by excellent analytical and communication skills. Regina's expertise includes data warehousing, quality assurance and testing in Unix scripting, as well as Pentaho reporting and analyzer. She has worked on data migration and data warehousing projects for large banking and financial services clients, creating transformations and data mappings for loading legacy data into data warehouse data marts using ETL tools. Today's topic covers use case, step-by-step instructions, and Q&A. Please remember to mute your microphone. You can use the WebEx chat feature to ask questions at any time, post questions to BizQ post, and our presenter will be answering questions after the presentation. Now over to you, Regina.
Hi everyone. Today I'll be talking about how to use the formula step in PDI. The PDI version I'll be using is 4.4. The formula steps helps you to calculate formula expressions within a data stream. It gives you a number of different functions to use from. We can implement simple calculations like addition of two numbers to complex functions like nested if logic, etc. It lets you combine several built-in functions. I've created two simple examples to demonstrate how to use the step. I'll open the sample. This is my first example. I've created two data grids, so just a sample data to explain how to use the formula step. So this is the formula step. You can just drag it from here, and if you would double click on there, you can see a new field, a formula, and a value type. So you can create, you can name your new field, give your formula in here, and whatever the result type of the value type of the result be, you can define it here. So if you click on the formula cell, it will take you to a formula editor where you can define your formulas. Coming back to my first data grid, so I've defined two numbers and two strings. These are the values I've given, so 10, 10 and hello world. And in the formula, what I'm doing is, the first formula is for adding up these two numbers, so just sum num1 and num2, and then the second function is for concatenating the two strings, so string 1 and string 2, and I'm using, you're able to combine different functions. So here I'm combining the upper function, the upper function and the AND function. So it will do an uppercasing to the string 1, concatenate it with the uppercasing for string 2. This one is an example of an if function. So just a basic if logic. So if number 1 is equal to 10, which is in this case, it shows a string 1, else string 2. This is is error function. So this function is basically, if you give a value that is error, it will give a boolean value of y, which is a boolean value of true, which indicates that it's an error of a result that we are getting. So if you have some division function and all within your data stream, it's good to define using the is error so that you can identify the error and then use a filter function to go the success or the failure part. And if you are defining any of the fields incorrectly here, it will give you an error message immediately. So if I delete that too, it shows that it's an unknown field name because the field names I've defined are num1 and num2. So just bring it back and it will be a valid function. So if I preview my formula step here, so these are the results of the functions. So sum numbers, that's my first function, gives num1 plus num2, which is 20, and concatenating the two strings, which is the second function. So it gives the hello world after changing the case of both those strings. And this is the if logic that I had implemented. So which is if num1 is equal to 10, just display the first string, else string 2, and in this case I have defined an error field which is 1 by 0, and it gives a boolean value of y because it's an error. And in the second grid, I have defined 3 other fields which has data like this, and the functions I have defined for those are, so just getting the first 4 characters from merge category and as the merchant category code, and then merchant category new as this string. So if this is when if logic I've implemented, so if merchant category is equal to null, the result will be null, else it displays a particular part from within the first string. So here I've used the functions mid and find. Find function will help you in getting the starting position of a given text, and mid will give you an extracted text from a given text. So all these are basically using mid and find function. So suppose let's take for example the region type code. I've used mid of region type. Mid function will give you an extracted text. So there will be 3 arguments for this function. So first you pass your string, and then the starting position from which you want to select your text, and then the number, the length. So how many characters you want after the position you have defined. So I'll preview my function. Here. So this is the region type I have. So SR hyphen sub-regional, and if we look at the region type code, you can see that they are getting just the SR, the first 2 characters. So how I have defined it is, so mid this string, and then finding the after given the length of that string which I want. So in this case, it will look for the hash, look for the hyphen within the string, and then it will. So the first hyphen, it will find it position 3, and then it is doing a 3 minus 1, which will give 2, and 2 characters from the first position will be selected, which gives SR or RR or MR. So in each case I'm defining, so region type new will be the text after that, and for merchant category also I'm doing exact kind of splitting, so getting the code and the characters afterwards. It's possible to use variables defined earlier in the formula step. So I've created a simple job to demonstrate that functionality. So I have a sample job. In the first, so there are 2 transformations. In the first transformation, I'm just setting a variable. So I'm getting a system info with the transformation name and setting it as a variable here. So the transformation name will be just set variable. You can preview it here and find it. So it's just set variable. And if I go to my next transformation, I have defined the data grid just as before, so 2 numbers and 2 strings. And then getting the variable from the first transformation I have defined, getting the field, joining the 2, and then defining the formula. So this is the function which uses the variable. So this test field is my variable defined earlier. So test, you can see that it is coming as ET. So I'm starting my position at the second, and I'm getting 3 characters afterwards. So it will exclude this s and it will get three variables, which is et and underscore. So there are different categories of functions that you can use here. So there is basic computation, such as just a normal plus, minus, percentage, etc. And then you have the comparison functions, which is less than, greater than, not equal to, etc. Some of the date functions are here as well, which is today, now, dated, etc. To show a simple example of a date, test date, I'll define a function called now, which shows the current time, and I have to define it as a date, and previewing, show you the date as today's date, which is a now, and then there are the information functions. So choose is basically used to select from a odd value from a given list. Then there is the if error, which I had shown you some time back. Then logical, which you can use and, or, if, not, etc. And mathematical functions, which are the sum, min, max. And then the text functions, which I have been using, like mid, find, upper, lower, etc. You can use the JavaScript function as well to define the functions, but JavaScript is the formula step is much more faster than the JavaScript step. So if you don't have complex functionalities like opening a file or looping, etc., you can use the formula step, which is much more faster than the JavaScript step. And that's it for today. Thank you. That's it.